by George Curelet-Balan, and he is normally always the guy behind the video. And today he will be giving a talk. Talk will be on naturalness of software, and it's actually how NLP can be used in software engineering for getting better code and helping out actually the software engineer. So it's a different way of looking at it.
Let me focus the camera. Well, let me stand for a few moments to popular demand. I was browsing, as usual, the main issue of communication of ACM, and this article kind of puzzled me that software is like English. And going through the article, it kind of triggered somehow old thoughts of mine about software development. So I put together some research notes and some of my own things. This is the name of the talk. NLP models in software engineering, or how intelligent software development tools can help developers. Article gist is that statistical properties of the research Big Java on Ubuntu project software corpora suggest that, like common English, software is natural, i.e. repetitive and predictable. This property can be harvested by leveraging predictable statistical properties. An older version of this article, published 2012, is at this website address. Was published by one of the authors. So the idea is the naturals of natural languages has been exploited by speech recognizers, translation engines, and optical character recognition tools, based on the fact that in the natural language, in a specific context, you can predict what's the next statement. Yeah, for example, in a news report, you can highly predict what's the next statement if you research a big text corpora regarding that domain. The article gives an example for like a political news report where it says if you have like a buzzing, that radio buzzing that you missed a word, you kind of can guess what that word is. So the statistical study of natural languages has recently had a big success. For example, in Google Translate, their approach is to use statistics instead of linguistics. Yeah, like knowledge parsing. So they realize that this approach is quite complicated and sometimes doesn't give good results. While if you go statistical way, you get fast, practical results, even though they are not perfect. Yeah, I mean, I don't know if you play with Google Translate. Sometimes it doesn't work as you expect, but most of the time it kind of gives you an idea what the translation is. So the compromise is to go for a practical solution rather than an academic, elaborate one that is not always successful and practical. So the authors, they quote here a research done in 2010 by Gagel and Su, that they studied a huge software code corpora, and they found for the first time that code fragments, some of big size, are repetitive too. They notice patterns where, for example, big code commits kind of in a big project kind of follow a repetitive pattern. So the authors, they give this example. For example, in C, Java or C#, if you type, for example, 4, then you kind of know what follows most of the time. Yeah, let's say 90% is increment by 1. You have a maximum for a counter, and you open brackets. Yeah. The motivation of the authors is that given a fragment of code, this time they go further, like for example, a token sequence or an abstract syntax tree or a semantic abstraction, you can kind of guess the rest if you have a good probability distribution of code fragments. And this distribution has low entropy. Now, natural language models are used to determine this probability of distribution of code fragments. In the 1999 book by Manning and Schultz, they show many different types of natural language processing language models. But the authors in this article, they use the Markovian N-gram model on token sequences. So they don't deal with semantic, more complicated or syntactic. I think the goal of the authors was to educate the audience about this new area. N-gram language model statistically model how likely tokens are to follow other tokens. For example, a 3-gram model predicts next token from the previous 2. The methodology is to use maximum likelihood frequency counting of tokens from the code corpora. So, for example, if you have n tokens, then the probability of AI being preceded by all I-1 is the same approximately with the probability of preceding 2 of I, item I. And now I was thinking how to give an example. It's not quite Markovian, but it involves symbol substitution, and this is like kind of a test for you. If I'm asking if you can figure out this, don't say it. I just want to say it's a little bit of out of the box thinking.
Take a minute, but if you read the whole thing and appreciate the second part, then you get
if you focus on so it is clear that you have words separated by blanks. Yeah? So you don't have to focus on each word. Yeah, you kind of have to look at the whole sequence and use your training in English language to figure out what are the words. Do you want me to give more time, or?
I don't get it. I feel like I'm being tested.
Okay, because I have some steps to make it to guess it. Yeah. So
wait, were you joking or serious then?
This is.
It sounds like you
It
told
was
me
actually a really good meta joke if you got it.
So.
Yeah.
Can you guess this one?
See, in the previous slide, what you had to do was take the second sentence and take some of the letters from that, because you could read that and put in the substitutions and apply it to the previous one, and then you could start filling that in.
Okay.
That was the trick.
I see.
So with this one, does everybody got it? Or? Who is hacker here? Yeah. They kind of
Lead speak, yeah.
can't figure out.
No, I think you mean who here was a hacker in the 90s?
Who here was
So
stereotypical?
now I try this one, make it much simpler. but this time I'm not substituting T, and I'm using dollar instead of S. Yeah. So instead of O, I'm using 0. So I'm saying, or this is a test. So I am substituting A with 4, and E with 3, and I with 1. And so if I go here instead of T, I'm using 7. And instead of S, I'm using 5. So this is kind of not fully Markovian model, but because it uses character substitution too. But it proves the idea that our brain, once you have knowledge about a domain, once you have a language model, I mean, once you are trained in a specific language, then to understand the sentences, you don't have to read each character in a word to get the sentence from the whole phrase. Using your previous knowledge, you can infer what's the meaning.
You know, there's a really good example where if you take the first and last letter of each word and you scramble the letters in between, you can actually read what it says. Like just take a regular sentence. Let's say sometimes, but quite often.
Yeah. So here is I'm saying, what about this? And so now it is easier to read, I guess. Easier. But if you play, at the beginning I was puzzled too, because I didn't know what it's all about. I mean, for a newbie, it's kind of shocking, but once you get the hang of it, then it's you realize. I mean, I was reading like, but that was in Romanian. I was reading like phrases of like 10 lines, yeah, very fast, because you match without reading each word. You just match from the context what the word is. So the author in the paper, they go into the details about the N-gram models. You can read it. I just synthesize here at the end when they say the N-gram language model is not perfect. So there are lots of challenging with data sparsity and application of smoothing techniques. And they cite a paper in 2 papers in 2014 and 15 where a new graph-basic statistical language model can give better results than previous research. This fact is not in the old version that I 2012. So then they define what is a good language model. They define the notion of cross entropy. You can see it in the article. And actually, intuitively, what cross entropy is that the language model is not surprised by a new document. That means it most likely guesses the right words. I mean, if it is stunned by a new word, that means something is wrong. So here I have another test. This is a test where you'll be surprised. So the translation of this one is indeed in Romanian, where I say, acesta este un test. This is a test. Actually, you will not be able to guess the meaning of this phrase because you are not trained in Romanian language. Yeah? So you don't have.
I know some Italian though, so I In Spanish for esta.
So this is an example of surprise, yeah, where the entropy is not low. Yeah. That means from a software point of view, this will be like a bug, yeah, in the software, because it doesn't follow the natural, repetitive and predictable nature of software. So how the methodology used by the authors to determine if a language model is a good one. So they compared the cross entropy first for a huge English text corpora compared against a huge code corpora. And then they compared the code corpora between different projects. I don't know, do you want me to define what corpora is? It's a machine learning, the term used where you have like a huge, eventually concatenated text or code, yeah, just a huge blob of input data. So in the first approach, they compared the low entropy of English with software code. So they used some well-known machine learning, Brown and Gutenberg corpus, and they determined the language model low entropy for this, and it compared with 10 big Java projects that are here, are listed here. So we see the number of lines and unique tokens and the total tokens for Java projects. And then below we have the Ubuntu domain applications. And below they list the English corpus used. And so the result was that the cross entropy with n-gram models was similar rapidly decline with the English. So they have this diagram here. On top we see how English low entropy is declining. On the x-axis we have the n-gram. That means 1, 2, or 3, 10 previous tokens are required to guess the next one. Yeah? So we see that this model saturates around 3 and 4 n-gram. That means if you have to guess from 5 previous sentences which one is the next one, it's kind of the same as guessing the previous 3. Yeah. So then they asked themselves what causes this regularity, and so they use this time a 3-gram model, and they train this model for each of the 10 Java projects, and they compare the cross entropy with each other, and they realized that the code repetition and predictability is not language related, but it is project specific. So they say they reiterated other research that realized that software is local. That means people are coding based on the domain of application, and the repetition reflects the domain and not the language itself.
For identifiers, are they abstracted out to just ABC, or are they actually just training it on the verbatim text?
Verbatim. They said they only the comments. They remove the comments.
Sure.
So they use
but like the loop thing that said you can get it to be I++, as a human looking at this, I'd want to also include J++, just with a different name on that counter variable, as being the same thing and predictable. But in this case, it's actually, that's why you say it's an intuitive result, because you know there are going to be different variable names in the different projects, for example. Like, you know, beyond counters, as you get into other variable names, they're obviously going to be different.
Yeah, that's a good question. I don't remember reading the article they mentioned this.
Would that possibly refer to a sort of a higher, more semantic level? Like I know there are three things you talked about: syntactic, and then the token level, and then semantics. And so, would that almost like be a more semantic level? I don't know, I'm just guessing here, but you know, basically the semantics is that these things are the same thing as you loop through.
They mentioned this towards the end of the article, like an open question, because they say you need to do like human-based studies to see if this semantics. So for them, it's like an axiom that needs to be proven.
Did they have any breakdown of what kind of projects made more verbose vocabulary sets or anything like that?
I don't know, have you been here when I showed the project?
That's where I was thinking. You can ask it later. It's okay. I can ask it after.
Oh, this they use this project, huh?
Right, but I mean, semantically, each of those projects have different domain specified, like specializations.
Yeah.
And each of those domains will be verbose in its own ways, and that may or may not affect the n-gram level or how many conditionals are attached to each phrase or each sentence that you would say. How many to's or whiles or buts you may say may differ depending on the domain of the problem you work on.
Yeah, I'm not sure.
That might also apply to English as well. Like if you compare like maybe something that was a big batch of legal text versus something that was science fiction stories. You kind of get sort of different.
They mentioned, for example, for English training, research regarding the translation. They use like Parliament of Canada proceedings that are bilingual, and they record everything. Yeah, so that's a good input data to study this. Then they ask the question if the n-gram model can capture the similarity within the projects, or and the differences between application domains. And here they use the 10 Ubuntu domains. We see that each domain has a lot of projects. Yeah, for administration has 116 projects, and they calculated the cross entropy within each domain and cross domains. So they noticed that there is more regularity within the domains, proving again that the software is local, and less regularity across domains. And I think that's related with your question, because if the domains are different, then it's hard to see some regularity.
So something just occurred to me. What if you sort of took each of the two domains sort of in a pairwise comparison and did like each combination, and then if they actually found some sort of like relatedness between them, like if then matched up in some sort of intuitive way, like for example maybe mail and text processing was closer in a certain way, maybe, and then graphics and sound was sort of similar. Like that way you could sort of actually test to see if there was actually some sort of relatedness there.
Yeah.
Like maybe sort of lower entropy between things that are kind of related. Like, or text and latex and text processing might be more similar or something like that.
Yeah, that's a good idea.
That would be a way to test your hypothesis.
Yeah. So here they show this regularity in Reddit self cross entropy, and in the bottom we see that the self entropy follows each follow each domain. So here, so this is like an empirical study. It's not 100% science, yeah. But so they say that these regularities we can use for code summarization and code searching. Code summarization is a part of natural language processing, where, for example, given a body of text, you want to get a summary of it. So they say, what if we can use this for software, giving a body of code? Can you find a tool to give you an English summary of what this code is doing? For example, it's sorting something, or yeah. But in code searching, for example, do kind of semantic code search, a kind of intelligence code search. One trivial example, for example, would be where you do like that web service access or something, the code, yeah. And so you'll be able to locate. And here, what you said, they say deeper semantic property will also often manifest themselves in local regularities. But this is kind of a statement, yeah, so they don't elaborate too much on it. So then they developed an Ngram-based suggestion engine for Eclipse. Eclipse already has a suggestion-based, and their model merges the Eclipse suggestion with theirs, and so they use this they tested this for 5 Java projects, and Maven, 4J, Salem, and Celsius. So they described the testing procedure where 40 files were randomly chosen for testing, and a trigram language model on the remaining file was built. And then they tested the prediction of every token in the 40 files chosen for testing. Yeah. And the results, they were quite pleased by the model, where they realized that 50% of each prediction was project specific and not Java based. And they compared their tool with the Eclipse built-in suggestion engine, and they noticed the decrease of keystrokes between 27% and 61%. Yeah, because you get the suggestion and then you have to pick which one is right. Yes.
How well does that compare to the built-in Eclipse suggestion system? How well does it perform relative to that?
Is that what that last line is?
Yeah. Yeah.
So it's 61% more efficient than no autocomplete, or 61% more efficient than Eclipse's autocomplete?
I think it sounds like they only compared to Eclipse autocomplete.
Right.
Yeah.
Oh, okay.
The confusion is that their system merges the Eclipse built-in with their. Yeah, they have an algorithm of merging the suggestion, but then they they tested their tool with the Eclipse built-in. So. Now, close to the end of the article, they make reference to other research done in this area. I didn't put here all of those, but they mentioned this BMM completion algorithm that is quite interesting, where they try to find the most likely method calls to complete an expression by using frequency of method calls and prior usage in similar circumstances. This is the paper, and the same authors, Brock and others, they have a vision for the next generation IDE, where they say that a natural language model which can capture the collective wisdom embedded in the software corpora that also record the human action. For example, all users that worked on specific code their actions are recorded, and they propose a next generation IDE that has some intelligence built in that, for example, will help maintaining the code. Yeah. So you record with a language model all the interaction with the software, and then when you do maintenance, you use all this intelligence to help you with prediction and software maintenance. Let me see here. The authors make reference to this approach by saying that their approach is more general because they don't focus only on the method calls. They use the whole software corpora. Another research was done in program synthesis. That means you have a software with holes. They say, for example, let me give you this example. We see on the right that you want to do some API calls, and they say, and I think that's true, that usually the API calls are done in a specific sequence. So they want to help you to suggest what that sequence is instead of you memorizing it. Yeah? So, for example, here we don't know what follows after for where we have question marks. Yeah? So there's a system called Slang was able, for example, here to infer what are the API's calls using language models. The article is quite complicated.
Actually, I gotta say, like when I start programming in a new area, like just getting a sense of which sequence of things, because you basically have a combinatorial explosion in terms of which function calls you got to do to get a certain type of effect. And so that's why I generally do search on the web to find out what that actual sequence is, to find examples of code. So I have to read the manual pages.
So interestingly, if you were using a tool like this, starting programming in a new area, it would actually be training you as you go, because you would pick up from its suggestions. Oh, okay, this is the order.
That's basically what I use Stack
The
Overflow.
beginning of the singularity.
They actually mentioned Stack Overflow and other like message boards that have embedded knowledge. Yeah, so.
Or Rosetta code as well. That was
I think I have a reference later. So this group based in Zurich, they have like here listed like 7 papers that they work in this area, and compared with the outdoor vision, they say you need also to do semantic code analysis to make like a better prediction. And they developed this nice to predict framework, and it's quite general. It's not language dependent, and I went to like very summary to the article, and for example, they have this unuglified.js client that they tested their nice to predict framework. I put it here just for reference. And then they have another tool, JS Nice, where they were saying how can you infer the types starting from obfuscated code. And they say they got better results than Google Closure or TypeScript or Facebook Flow to infer the types. So they do machine training, on the code corpora. Then you give an obfuscated code, and it will, based on the training, it will infer the types.
And the variable names, apparently.
It's good for people who use crazy variables. Keep them in check.
This tool will tell you when you should have named your variable.
Yes, exactly.
You know what I would like? Sort of code where you have like a sort of a more inflated version for documentation purposes, but then you want to actually study the actual algorithm itself and crunch down to the left side. Just but you know, so that way you sort of just toggle views, because sometimes when you have really big code that's got lots of comments and a lot of like extra bracket stuff, it kind of obscures the actual algorithm. It's kind of hard to understand what it actually is. You know, like you know, again, comparing say Haskell, which is so so tight, against like other languages where they spread out over so many lines.
Yeah. Here is another research by a team where one of the members is the author of the original paper. Yeah. So they did the study of bugs in the software corpora, and they realized that buggy code is not natural. Yeah. I mean, you can identify the bugs just by doing this language model testing, yeah. And they realized that as you are fixing the bug, the software in that area becomes more natural. Yeah.
Oh. The entropy drops.
Yeah.
Okay.
Yeah.
Is that what they also use for grammar correction? I have no idea. Like, is that what they use for grammar correction, like in actual English? Like,
Oh,
so-
definitely.
Okay. So those are bugs in English then, okay.
Yeah, they mentioned here, I'm not familiar with these static bug finders. We see the third line from the bottom, PMD and find bugs, that they use their warnings to identify the bugs. Now I found just another paper that's not a language model, but it's a neural network. I've been just puzzled how much research is in this area. This is a paper that was by Google Brain folks that was awarded. They are using neural networks to compose lower level programs to express high level ones. I just have a short reference. I didn't have time to go through it, but I found quite interesting that they try to use the AlphaGo expertise and move it into the software analysis, and to build some intelligence.
But isn't this optimizing the wrong thing? Because the time gets spent on reading code, not on writing code. So doing this is going to make less readable code much quicker. Potentially.
But if you can write code fast enough, then you never have to read it. You can always just throw it out and do it again.
Also, it's like if you run this on like say if you run this on like some bytecode representation, the actual code is like less optimized for compilers. So sometimes maybe you should find out.
And I found lots of interest. For example, Microsoft. They have this Pacific Northwest Regional NLP workshop. Lots of talks in this area, because even though the tools give some practical results, they are not perfect. Yeah, and there are lots of challenges. I mean, they quote a lot of errors that some of these models can run into. Yeah. So there are lots of interest in this area, controversy too. Because there is first a controversy between knowledge and linguists, yeah, and statisticians, yeah, because the later ones, they have good practical results, but sometimes their models fail because they don't consider the linguistic part, yeah. So, but on the other hand, if you go on the linguistic part, it's hard to solve the problem. So, So now I'm just I'm giving some scenarios from based on those things, some of my old ideas of what an intelligent software development scenario would be, like kind of for example intelligence of steroids, where I'm saying from personal experience sometimes you don't remember example a function name. Yeah? For example, you are programming in C. Yeah? So how many headers you have? You have like 15 or 16, and how many API calls are there? So why you have to remember exactly the function name? I mean that knowledge is already there. Yeah. So you have like a language model trained for that. You could either just do abbreviation, and this evolved intelligence can suggest you exactly the right spelling. Yeah, or even more you can give in English. If you are really beginner, you could say, I want to convert integer to ASCII. Yeah, and this intelligence, advanced intelligence, should you suggest exactly the API call. Yeah, so it's kind of information overload that right now we all deal, and the intelligence is there, but we are not taking advantage of it. So yeah, I'm saying here because it is easy to recognize than to generate. Yeah, I mean, if you ask, I often find the situation at interviews. Yeah, I ask a question, I know what's about, but I cannot identify exactly the answer. But if you give me like a multi-choice, I can point to the to the exact answer. Yeah. So I mean, this is psychology stuff that. The domain is the same thing. Yeah? It is easy to recognize than to try to remember and to generate the knowledge they're looking for.
But I mean, we've been doing this for 20 years now. We've been trying to do this. Right? 20,
Yeah.
35 years we've been sitting in front of auto-generated code going, this is garbage, throw it out, I gotta write something.
Yeah, because we don't have enough intelligence there. So I'm saying we have Syrian Cortana, yeah, like intelligent assistant for a normal being. Yeah, if you could have one for software development where the knowledge space is smaller. Yeah, I mean you can, for example, if you are programming in C, you have a restricted knowledge domain. Yeah, rather than let's say the whole English language. So it's like intent based. Yeah, you state what's your intent, and this tool should help you to suggest how to do it. And sometimes we are saying, "Oh, I'm rusted in this thing." Yeah, why you're rusted? Because you focused on other areas, and it is normal to forget if you learn something new. So. If you state the intent and you play with such a tool for a while, you become fluent. You are not rusty anymore. Yeah? So,
to a certain extent, that is basically what Google is trying to do all the time. But it sounds like maybe we almost need to be able to do search queries in Google where we could sort of specify kind of like a keyword before a search term to sort of say, this is the domain I'm interested in, and this is what I want to be searching on. Kind of like, how like. The simple example would simply just be site : and you restrict it down to a site, right? But you could simply say, I'm interested in this domain of programming, and then I give my general query. That way you can almost get a little more sort of additional semantic information of the queries you're doing. Because, I mean, to a certain extent, that's almost what Google is kind of providing in a certain sense, with Stack Overflow being sort of the natural companion.
Yeah, Google's already pretty good at that.
Yeah.
It's very rare that I type something in and it gives results from a completely different domain than I would expect. So I'm sure they're doing work on that.
then we talk about this summarization. Yeah? For code translation, yeah, they already I've seen cited tools that do two-way translation, yeah, between two languages. For example, between C# and Java. Yeah? But the authors mention what if you can put the problem, what if you want to translate between English and a specific programming language. So you state in English what you want to do, and you have the code generated. And the reverse, the code summarization, you give the code, and and it gives you in the English what the code is doing.
One COBOL, because I feel like this is going to this is a dangerous route to COBOL. Just
And this can have a huge impact of software maintenance for like big projects. Yeah, if you have lots of code, yeah, maintaining it, we all know that's a big problem. So the ideal scenario will be you input some code, this intelligent software development tool documents it, extracts eventually architecture pattern used. You can ask, for example, where this pattern is used in the code, yeah, and it can find exactly the location.
So does it have a similar thing for error codes for people then?
For what?
Does it have something similar for error codes for people that reads like, you know what I mean? Like, if you have a machine that breaks a certain way and it just says error, like, call a mechanic.
Yeah.
You know what I mean? Like, you're limited with your tools and what you're given. If you only give me a limited set of vocabulary, they'll say that, and then the system breaks. I'm like, oh, okay, well, I'm out of words, so I got to call someone with bigger vocabulary. So, like, they sort of have to do it the opposite way too. They have to look at it big top down. They have to look at, okay, what are the error codes coming out of it, and how do we translate the error codes into something like meaningful that somebody might actually act on?
Yeah. I didn't see any mention of this, but
No, you
maybe there is there. And then I mentioned this like intelligent code search, yeah, like semantic based or finding bugs. Like we've seen that article with naturalists or not naturalists of bugs. API navigation, like was that slang tool where you see the sequence of API calls. Another one like idiom mining. Yeah, this is a tough one. Yeah, where the specific idiom is used in the code. Yeah, especially in C++. It's kind of hard to find. Yeah. And then I was thinking why we can think now. That's time for these tools. Yeah. And I was remembering that in the 1980s I was studying computer software engineering tools that were like in vogue at that time, and some of the tools had have good results. For example, IBM rational tools. Yeah, when they help you in the life cycle, you track the requirements, you link the requirements to the code, and people's comments and fixing and so on. But the intelligence is not, in my opinion, from what I know till now, it doesn't have the intelligence we were talking till now. Yeah. For example, you could say if you focus on specific area of code, you know, what is the history of this code evolution? Yeah. How many times? Yeah. Was this area of code bugging or not? Yeah. Things like that. And why I think throughout the time, because we see a lot of, and I don't think it's a hype, yeah, in the literature about the advancements in the language translation and artificial intelligence, AlphaGo, for example. Yeah, it is a reality there that real results are there in the artificial intelligence, yeah, capturing the human intelligence and using support. I'm stating maybe the computer-aided software engineering tools are ready for a renaissance. Yeah. And here, if you are not familiar, artificial intelligence now is in vogue because it has the up and down cycles. Yeah, I'm quoting here in Wikipedia, AI winter phases, and I think around now it's AI spring, and I mean make a reference to AlphaGo. this was like a big success for artificial intelligence. Their success were better than IBM Watson that was like rule based. AlphaGo uses heuristics and probability search in the reasoning space to find the solution. And the success was so big that people were becoming afraid of artificial intelligence. Bill Gates and Musk and other guys. They kind of started to warn people about the danger of artificial intelligence. Recently Google, I think it was a few weeks ago, they issued some guidelines about artificial intelligence safety that people need to follow, so that
Certain laws.
This is the article where they state what are the guidelines to keep artificial intelligence safe. And then another reason I think that now is the time for ISD is because of high performance computing. We have it with the cloud and the supercomputers, and a huge volume of open source software. We have GitHub, Bitbucket, Codeplex, SourceForge, and the forum that have code samples, have English with code. So it's kind of interesting to research. And the DARPA started to be interested in the big code area, so they have this project now, Muse, to research software intelligence. And the third reason I found why ISD is now is of the software crisis, and the debates, with agility and waterfall, and here I found a quote in Wikipedia about software crisis. In 1968, actually, they first realized that the software is in crisis, and actually this gave birth to the waterfall model. But I believe that the software is in crisis since then. Even now, I think it's in a bigger crisis because of huge volume of code you have. And for big projects, the issue is to maintain it. I mean, the green projects, everybody wants to work on a green project because it's so exciting to develop a new product. But then when you want to maintain and the project grows, it becomes nightmare. So I see a lot of references in the literature where they are saying, usually with the startups, they develop some block of code, and they reach a moment where adding new features is very difficult. So then they either scrap everything and re-architect in a new technology, or they do incremental small changes to the existing code.
You just hope Google buys you before you get that big. You just hope Google buys you before you get that big. That's every startup's actual software maintenance strategy. You write this much code, and then you write this much code, and then either Google buys you or you go bankrupt. You don't maintain the code. That's not. You don't do that. You go start a new startup.
Or if that fails, build an incubator.
But now Google has its own problems to maintain its huge, big software code.
So when you go bankrupt, then you go and join Google and maintain some piece of code that Google built.
And then we're not looking to rip off their idea and make a new startup.
They just want your patents.
Well, I was just searching this article myself, and I was looking for technical debt, because I think that is actually one of the big issues. Ourselves as software developers, we look at something and we think, well, this isn't really right, and if we had the time to refactor it properly, but because of financial pressures and time deadlines, we can't really do it, and so that might actually be a big factor there. Having the chance to actually properly refactor it and sort of like you don't really understand the objects well enough, and that's because maybe you had to improve your model some more to actually make it comprehensible. And there's just all kinds of it.
But even the technology evolves, yeah. So it looks like right now object-oriented development is not by the stark technology. Yeah, there is a functional approach, mixed approach, or So when let's say you started a few years ago a big project object-oriented way, and now realize maybe the architecture was not right. Or even, for example, the software patterns. I was reading recently an article where we were saying that the Django 4 software patterns were developed for C++. Yeah, actually. But if you take new languages, some of the patterns don't fit quite well. Yeah, so you have kind of yeah.
Yeah, but I mean, we just don't. The tools of programming have evolved so quickly over the past 20 years that we just don't code like we used to even 10 years ago. Right now, we just grab off the shelf. Okay, we're gonna grab this, throw this project, put some glue on it, ship it out. We don't do it like we used to do it like 10 years ago.
But if the software grows, you still have a software crisis.
Yeah, fundamentally, you're still the same problem. You still got to replace it.
I think that the reason is because you don't have intelligence. You don't have intelligence about that.
I
that
do agree.
software.
The reason is that we do not have intelligence. No doubt about that.
Captured intelligence. I think the thing is it's intrinsic, yeah? I mean, we go back to the essential complexity of the software. So I see that ISD tools, these software development tools, intelligent, as a way to see the software architecture. Yeah? Recently, Grady Butch has a wonderful talk about abstracting the unknown. Yeah? The role of the software architect in the agile world. Yeah? There is always controversy between waterfall folks and agile folks. We need an architect, we don't need an architect. Yeah? So he says that agile people have said you don't need architecture because it is in the code. And his question is, can you show me? Can I see that architecture in the code? If you have only the code, you see the code, you don't see the architecture. Yeah? He proposes like you're using UML modeling to parallel the software development with coding, and a way to see the architecture. I think if you have these intelligent software tools, you can query the code where you are maintaining about that software properties. So, I will end up here.